Hi, everyone. Are we awake? Everyone sufficiently caffeinated, excited? All right. So, welcome to day 2 of Open Hardware Summit. You guys have sort of chosen the panel track. Hopefully, it'll be insightful and interesting and useful, I think, most importantly. So, we have this first um, panel session this morning is a long discussion on open source environmental monitoring. Roughly, I think we're considering the format's going to be, there's going to be some speakers here for the first, approximately hour or so. And then we'll move on to sort of Q&A and open discussion and see where we get after that. And we'll direct it as need be. So I believe we have 3 speakers today. We'll kick it off with your Joe, correct? All right, I'd like to introduce Joe Walsh, who is a research software engineer at the UK Centre for Ecology and Hydrology here in Edinburgh. New both to open source hardware and environmental sensing, they've attained a fellowship from the Software Sustainability Institute on the theme of applying the same principles of reproducibility, reusable open source research software to hardware. And Joe, I will hand it over to you.
Thank you very much, Kat. I hope, can you all hear me okay? Welcome to the panel. I'm Joe. I'm very new to all of this, both to open source hardware and to environmental sensing. So I've come to put my naive optimism on display, but also to bring some cautionary perspective from having seen how some of my past work has been reused. So I'll run through a bit of my backstory, talk about some of the both open source and proprietary hardware work that's being done at the UK Centre for Ecology and Hydrology, a bit about the fellowship I've been offered, and then hopefully have time to get into some philosophical speculation. So this picture is from almost exactly 20 years ago. That's me in the green t-shirt. You can see that I've hardly changed at all, although some of the retro tech does look a bit different now. And this was taken at the first OpenStreetMap mapping party in London that I co-organized. At this time, I was a software artist working on community wireless networks, doing locative media arts, and on this side track to do open collaborative mapping so that I could go on to do the projects I wanted to. And that involvement, it changed the course of my professional life. I'm currently a research software engineer, and for about the last decade or so, I've been working my way through different organizations that do different kinds of land surveys. And I'm currently with the UK Centre for Ecology and Hydrology, where I've been for about a year. I'm here with my colleague Rob, who is an instrument engineer, effectively research hardware engineer at CEH here in Edinburgh. This picture is of Lake Windermere. It's one of CEH's long-term monitoring sites where there's a record of continuous sampling going back to the 1940s. So the institutions which came to make up CEH, which UK CEH, which is now a charity, have got a very long heritage. One of the lovely things about the organization is that it's got a kind of an in-house hackerspace, the engineering workshop in Wallingford, with smaller workshops in the other field sites. This is one of their prototypes that they've developed with field researchers. I love this because it's not electronic at all. So it's a river flume with ceramic plates that are infused with different chemicals to observe how algae grow. And I had a lovely conversation when I visited them about the engineering challenges of making a buoy that would neither fully sink or fully float. We also do some training which involves open source hardware. We support other organizations to develop field electronics and sensors. This is our colleague Neil, delivering a sort of electronics, delivering a field electronics and sensors course. This is Alba Gomez Segura, member of my team who sadly since left, with the AMI system. The AMI is an in-house equivalent to the Mothbox. It very slightly predates it. It's the same principles, but it isn't open at the moment, and it feels like a lost collaboration opportunity. And that's the sort of thing I would like to learn how to prevent from happening again, with the input from the audience here. Finally, this is a more contemporary field site. This is from a project, a very large infrastructure project called the Floods and Droughts Research Infrastructure. So when we're building out these potentially multi-million big installation sites, we're still using proprietary hardware. I didn't bring along the Campbell data logger because I was terrified of losing it in the pub. But here's this, you know, it's a brick that pretty much fills this box. It costs £1,500, with functionality pretty much equivalent to this, which is the I'm getting well, with functionality at least roughly analogous to this Adafruit feather, which is used in the field electronics workshop. So as part of FDRI, there is an innovation strand, which is building out LoRa networks and encouraging people to bring their own device for field installations. But this is very much seen as an edge activity, something that's happening away from the real science. And that's also something that I want to change. So soon after I joined the organization, I was sitting in project meetings, learning about the cost of these installations, about how previous ones were being decommissioned because they're so expensive to run, and thinking to myself, why aren't we treating hardware in the same way as we treat open source software, as essential to the practice of reproducible science, with specialists like myself on the software side supported culturally with incentives that funders can build into applications to mandate open source hardware. And I think is it Andrew from Mothbox yesterday who was saying, if you can't reproduce it, if it's not accessible, are you really doing science? So the Software Sustainability Institute then put out their call for fellowships. This is the older model of their T-shirt slogan. I've got the slightly more up-to-date one here. Better hardware, better research, rather than better software, better research as the foundation for making your work more accepted, more widespread, more reproducible. So their fellowship scheme, it's open to well beyond research software engineers. There's librarians, there's teachers in the current cohorts. They offer you a fund of £4,000, which you have a year to spend on community organizing, workshop developments. So I applied for this with the concept of trying to bring together, organizing a few workshops that bring together field engineers with tinkerers, hobbyists, people like Concrete Dog running small businesses, and making use of the facilities in the UK's network of hackerspaces. This is a quite representative picture of the Edinburgh Hack Lab, featuring 3D printed protective cat ears that you must wear while soldering. And the SSI accepted this application. I was very much hoping to run a workshop in the days leading up to this conference, and I have not done so. And the rest of the talk is going to be about the reasons why, and the kind of knowledge that I'm looking to build and input that I'm looking to get. One thing I realized quite quickly after making the successful application was how much groundwork there is out there. So not only on the device side, with projects like Shannon's Mayfly, with the Audio Moth family of devices, with the Mothbox, but also how much really sophisticated thinking and groundwork has been laid by people who are active in the field. This is a lovely recent paper by Julian Sterling, who is the founder of the OpenFlexure open source microscope. As it says on the tin, open instrumentation is key to reproducible science. We need to build incentives for it to thrive. So there's an awful lot to pick up and position, both in terms of the thinking that's been done and the building that's been done. And what I'd envisaged as a very kind of craft workshop, hands-on participatory exercise probably has to take a step back and partly be more grounded in the field, but also be more conceptual. So this picture here is from the work of Libby Miller, who up till last year had spent quite a long career at BBC R&D. And this is a futuristic mushroom sensor from the year 2035. I don't think it's actually implemented beyond being a design object, but they developed this in workshop settings with groups of 8 to 9-year-old kids as a really participatory thing. Libby's got some wonderful essays about prototyping and power and the importance of having physical prototypes, having tangible interactive objects, moving ourselves away from a screen-based setting for our participation. So, I'd like to see this as part of a practice of social invention and bringing researchers and hackers together as peers rather than the dynamic we see at the moment, which is very much, I've got some work I want to do in the field, bring it to engineers, please implement my science. I think that it was Helen's talk yesterday that talks about bad ideas and terrible ideas. And I'm not picking on this project of Jenna Lawson's. Conceptually, it's really interesting. So this is by one of our colleagues in a group that does a lot of AI analysis work. This is a bioacoustics project, and what you see up there is a drone, and it's shooting micromoth devices in projectile form into different levels of the tree canopy to observe the soundscapes of birds above and below. I'm not sure where this field site is. I think it's a test. A lot of Jenna's work is out in Costa Rica at the moment. And I look at this and think, is there some other way that you could have done this without starting to equip drones with listening projectiles? Apparently, yes, you could have strapped them to birds, but there would be too much interference from the flapping of their wings. So, we are, as inventors and as researchers, we're all prone occasionally to have terrible ideas. And I want to be able to think through the potential negative side effects, the consequences of what we make, of what we create in different pairs of hands. So to refer back to some of, how am I doing for time, Kat? Should I, so to refer back to that work from 20 years ago, a group of idealistic hackers and artists was running around talking about the power of pervasive, ubiquitous computing and how this would cause this wonderful serendipitous social transformation, and it has not really worked out like that. The other reference point that I've got here for wanting to be very careful in how we conceptualize what devices we are developing is this. It's the work of Dan McQuillan. So Dan McQuillan is an academic in London, has a book which is a few years old now called Resisting AI, and a term that Dan is propagating at the moment is decomputing. I've got a short extract here because the wording is lovely. Decomputing takes the idea of computing within limits to refer not only to the scale of computational machinery, but the limits of extractive and colonial logics, limits to a biosphere's ability to recover, limits to our Western knowledge systems, and limits to tech solutionism. So I want to try and bear these words, these thoughts in mind while developing potential installations, infrastructure, concepts that have inbuilt within them what Dan McQuillan describes as a built-in resistance to scale, and taking the built-in rejection of scale as a heuristic for the way forward. Otherwise, I'm prone to terrible ideas like this. This is my dog backpack, Loran Gateway. Obviously, the dog's out for a walk anyway, and it's picking up data as it goes, and then it meets fellow dogs at a tree, and and I don't want to start strapping backpacks to dogs, but there are, I spoke to a very senior colleague of ours at UKCH who's a freshwater ecologist, but also a tinkerer. And she told me this story about how she'd built an electric fence for slugs in her garden using the conductive properties of the slugs themselves, and put a very small voltage through them to stop them eating her plants. And that had worked for a short time. And then the slugs got used to it and started crawling over the electric fence. So she increased the voltage slightly, and then that worked for a short time, and the slugs got used to that. And you can see where this story is going in terms of we end up with a strip of fried slugs, and there, there's definitely a collective inclination to decide that we could before we thought about whether we should. That I wish I'd thought through the implications of a bit more carefully, rather than suppressing them when I originally put the funding application in. But I've got the budget now. I'd love to reach out more to both communities. There's a year left to spend it, and this is currently where we're starting. This is the pond in our Edinburgh office, built by resident researchers a few years ago, and it's flourishing now. It's full of newts and tadpoles and little beetles and snail things, and we've had one kind of very free-form rambling meeting there at the pond side, just talking about, well, what could we see? How could we put in installations that are not intrusive and tasteful? How would an underwater camera work? Do we want that down there? Not collecting, but trying to put together and see the combined impact of someone's idea for a tube that newts crawl through. I'm not sure how he'd get them into the tube over here, with someone else's off-the-shelf tiny portable microscope over there, and have a bit of brainstorming in the field first before trying to bring anything back to the workshop. And I think that's something else that Mothbox Man was also emphasizing, the importance of starting this work in the field and living in the field with it. Thank goodness, that's pretty much me. This is a last kind of a plug / uptick. This is the mini Picasso 2. I love this. It's an open source hardware project that started as an April Fool's joke. And so you read this article about this wonky board and the reasons why electrons like to go on a circuitous journey, and then discover that it's a shippable product in kit form. RC 2014 is not at this conference, probably should be. He's at something called Retrofest. So that's my gratuitous plug. That's a page of links, most of which are somewhere below the floor, but all of this stuff is on Codeberg. And please come and talk to me afterwards. Thank you.
Okay, well, thank you, Joe. I would welcome everyone. We have people trickling in. So just as a reminder, we're going to do a couple short talks, a couple 20-minute talks, and then for the last hour, we'll just kind of have more of an open panel. So next up, I want to introduce Shannon Hicks, correct? So Shannon is an electrical engineer at the Stroud Water Research Center in Pennsylvania, where she designs and builds a variety of environmental sensor data logger systems using open source hardware and software. And she's the co-founder of Enviro DIY, an online community of users who share ideas and solutions for low-cost environmental monitoring. Shannon is also the developer of Mayfly Data Logger, an open-source Arduino-based board that makes it easy to build monitoring stations with sensors and telemetry. She's taught a bunch of workshops to a wide range of audiences on how to use open-source tools for environmental monitoring and research. With that, I'll hand it over to you, Shannon.
All right. Good morning, everyone. Yeah. So the fun part about this is that I am an electrical engineer, and I'm usually talking at academic conferences to people who know nothing about hardware. So most of my presentations are justifying low-cost hardware for doing environmental research, and I don't have to do it with you guys because, as we just heard, like the instrumentation that the scientists I normally work with are used to spending $1,000, $2,000 just for a box that maybe will record a timestamp and 2 or 3 values from a sensor. And then when I say we can do this with a $5 or $10 part, they really don't believe me. So I have to spend all of my effort explaining how to, use low cost equipment to do what I think could be done. So I've been experimenting with electronics like this for over 20 years. I've been at the Stroud Center. It's just outside of Philadelphia in eastern Pennsylvania. So I've been there for about the last 15 years. I'm the only engineer that I work with about 40 or 50 scientists that study everything from bugs to fish to weather to soil, chemistry, a lot of different things. So I get the fun job of making stuff work with whatever electronics or hardware or software, anything that I can find. So I'm going to kind of show you a few of the things that we've done over the years, just to kind of give you an idea of what we're doing. And as I said, this is kind of a combination of multiple talks that I've given at various times. So we're going to just kind of see how it goes. Enviro DIY was a program we started. It's really fun in the US. A lot of people are like, DIY, what does that even stand for? And then I go other places and it's like such a common term. But the idea was that wherever we would go and explain, hey, we're taking a data logger box and we're going to put it out in the woods and make it waterproof. Well, we get a lot of questions. No matter what the hardware is inside it, people are asking, like, what kind of case do you put it in? What kind of solar panel do you use? How do you put a sensor in the woods so an animal doesn't eat it or a storm doesn't wash it away? So we started just kind of this forum online of where anybody could come and post information or tips or things that they've learned, or, hey, look at this cool supplier like Andy that we started yesterday with his moth box. He told me about that amazing battery that they put in there. And that has, like, I didn't realize that. I'd been searching for an amazing battery, and he had already done the research to find a battery that worked in the jungle. So people like us sharing ideas of one component here or there can really change your design and really help out what you're doing. So we started this forum about 10 years ago, or almost 11 years ago now, where we were explaining to people how to do this. Well, then they said, well, hey, can you come teach a workshop? Can you do this? And so we ended up writing manuals and developing videos and tutorials. And I've gone all over the US and Canada. I've been to South America, Central America, teaching workshops and lectures about all the different things that we've done with this. And the whole idea is just to encourage people to build your own instrumentation for doing environmental monitoring with low-cost hardware. So the big thing that funded a lot of this project was in, I guess, around 2016, we got a grant to study the Delaware River watershed. So if you're not familiar where we are, Washington, D.C. is down here at the bottom. New York City is right in here. And this entire watershed has the drinking water supply for about 15 million people. It's one of the most heavily instrumented watersheds in the United States because of where they started a lot of monitoring back in the late 1700s because of where they were using the water from the rivers in Philadelphia. So the government has millions of dollars worth of instrumentation in this area, but only on large rivers where it really matters. What they are not able to study are the small streams. So what they asked us to do was to work with about 50 different watershed groups and schools and community groups, organizations, to deploy sensors that would measure conductivity, temperature, and water depth, and also turbidity, so the amount of particles in the water. And they wanted continuous data recorded every 5 minutes that would also be transmitted online to a data portal. And this would cost tens of millions of dollars if you were using commercial off-the-shelf instrumentation. And they wanted over 200 of these stations to go out. So I said, let me design something. So I did. And this is the current map as of a few months ago. You can see every one of these green dots is live data that's being transmitted to our database from these instrumentations. So how did we do this? So I started in 2015 building a little board. It's essentially it's like a beefed up Arduino Uno, except it's got a bigger processor on it. It's the Atmega 1284P, so it's got a few more pins and some more memory and things. And as soon as I built this board and it kind of did what we wanted, I added more features and more features, and every year, more and more things, while we were currently testing dozens or sometimes hundreds of the current board to get feedback of what worked, what didn't work. And then in 2021, this was the latest and greatest version that I've got. There's all sorts of really cool features and things on it. We even developed our own LTE cellular board because we couldn't find a commercial board that was doing cellular transmissions that we liked. We've got an ESP32 for Wi-Fi and Bluetooth, a little OLED display so you can read the live data while you're out in the woods doing field work. And you can see on the board, there's a whole bunch of different features. There's real-time clocks. There's solar battery charging circuit. It runs off a 3.7 volt LiPo, but you can generate 5, 9, and 12 volts with boost circuitry, so you can power sensors, because most sensors are, well, there's like 50 different varieties of sensors in terms of voltages and communication protocol. We've got onboard memory card storage. I forget all the various things, and this is just some of the highlights of what's on the board. So once we started making these boards and people said, okay, now I've got a circuit board, what am I going to do with it? So we developed this kit where you get a waterproof box and a solar panel and clamps and cables and adapters and brackets and a SIM card and all this stuff. And you have to buy this stuff from like 15, 20 different vendors. So we buy all that in bulk and then package it all up and give it to you for one low cost. And then now these people are buying these kits, or we also, it's 100% open source. So we share the source, the bill of materials for the boards if you want to get them. We sell the shopping list of where you can go track down all those materials and where to get this box and where to get the cable glands and where to get everything. But once we started sharing the list, people said, okay, now I have a list and I have a bunch of parts. Can you help me assemble it? So we had to develop workshop programs where people could come. Usually it's like a 2-day thing. And on the first day, we just teach them about Arduino, like how do you turn on a LED? What is an LED? Most of the people that are doing this are not programmers. They're people who want to do environmental monitoring. They want to measure something out in the woods. So we have to kind of give them a little bit of background, but we don't want to scare them away with, really hard coding experiments. So we have to kind of work through some examples to get them up to speed of what they need to do to adjust the sketches and how to get comfortable connecting and disconnecting electronics. So then the second day is we go and show them how to, take a waterproof box, drill a bunch of holes in it, then make it waterproof again so that you can get the cables in and out of the box. So we teach them about that. We teach them about the different types of sensors that they might want to use. And then day 3 is a little bit of the deployment, but also the maintenance. As soon as you put something outside and you're taking data, you're going to have to maintain it. Things are going to happen. Bugs are going to eat it. Things are going to, the sensors themselves will foul just being in water. So just sticking a sensor out there and saying, okay, we're all good, it's going to work forever. It never does. Something like 75% of the budget of the US Geological Survey is spent on maintenance of existing stations, like all of their personnel. Like putting one in is not that hard, but maintaining it and keeping it working and accurate is the hardest part. So what can you hook up to these things? Pretty much everything. There's one sensor we found that has a proprietary output that only works with this one proprietary data logger, and it's about a $4,000 sensor, so most people are not going to be using that one. But we've never encountered a sensor besides that one that we couldn't talk to. So you can do analog, digital, Modbus, serial, pretty much anything. Sometimes it needs an adapter. We have a whole bunch of different little adapters and connectors and different things you might need to shift voltages or do something that you need to be able to communicate with it. But then we also write the software. It's all shared on our GitHub repo where you can, it parses the data from the different sensors and will handle all of the behind the scenes stuff so that you can send it one brief command that says, take sensor data. You wait a certain amount of time, the data comes back. It might be an analog read, it might be a digital read, it might be a serial conversion. There's all sorts of different things happening, but we've written all of that into the software that we share. So then, okay, now you got the sensors, you've got the logger, what are you going to do with it? So these are just some of the examples. I've personally deployed over 300 of these in various places just in our area of the US. But we've got them on farmers' fields looking at runoff. We've got them on streams. We've got rain gauges. We've got them out in the woods. We've got solar sensors, weather sensors. We've got them on floating buoys. We've got them on things out in the ocean. We've got them on lakes. We've got sensors buried under cornfields, all sorts of really interesting things. Now that you've deployed dozens or hundreds of sensors in the woods, things are going to happen, right? So this is why having online data is really important, because if your sensor someone opens up the box there and steals the sensor and you no longer have data, you might not know about it until you go visit it next week or next month or whenever your next visit was. So sometimes squirrels will chew on the solar panel cables and now your battery won't be charging anymore. So a lot of times in the old days, before online live streaming data, you would just put your data logger out and go out once a month and hope that it works the next month when you were there. Now you get live data feeds to know whether or not you need to go maintain your station. Is it fouled? Did it get washed away? Did it get stolen? And it can really help increase the quality of the data you've collected because of this online data feed. The hard part is this stuff is usually expensive with commercial subscription plans. With ours, the data card that we use, it's about a $4 to $5 a month charge for the data plan, sending data every 5 minutes. So we had to develop a website called Monitor My Watershed. We share the code for how this works also. You could have your own version of this on your website, or you can use this where you stream the live data and you get sparkline plots of all the different parameters. And you could do time series analysis. You can turn on and off the different parameters and compare watersheds and different sensors and zoom in and zoom out and do all sorts of fun things. And one of the really interesting things is once we started collecting 5-minute data on these small streams that no one had ever been able to instrument before because of the cost, we started seeing really interesting pulses of things like conductivity in February and January. So in the US where we are, whenever the roads start to get a little icy, they just go out and throw salt everywhere, which is great for the road. It helps melt the salt. And most people don't think about what happens when the salt mixes with the rainwater or the melted snow and just goes into the creek. So if you see here, there's a big pulse here, another one here, another one there. Basically, as it warms up in the afternoon, you get a big flush of salt going into the stream. Here's a storm where multiple storms were doing the same thing with salt flushes. But we also see it even in March, where it wasn't even raining. So we had some scientists that were worried about this, so they went out and they tracked it down using handheld meters and online data. And what they were able to find was coming from this one parking lot was this extremely high levels of salt. And it turned out there was a giant pile of salt that was just sitting in a parking lot that the tarp had blown off of. And every time it rained a little, the salt went into the stream. So, but why is that a problem? Well, and then this is another area where we had each one of these green dots is one of our live data loggers. We had volunteers go out with little test strips to something like 75 different sites within 4 hours on one afternoon so that they could read the health of all these tall little streams here near Westchester, Pennsylvania. It's about an hour west of Philadelphia. And what they found is that the majority of streams in this area are impaired. And what do we mean by impaired? I think I had a slide back here on this one here. Seawater has a conductivity level, chloride level around 19,000 milligrams per liter. This tiny little stream that we were seeing was more than twice the salinity of seawater in a small stream where there's small fish and amphibians and microinvertebrates, things that really don't like salt water. So if you can imagine being a fish in a happy little freshwater environment and all of a sudden all the salt comes through, it can do that for sometimes days, but usually just 6 to 8 hours, 12 hours. That's enough to damage the ecosystem that's there. And nobody really knew that the streams were this polluted because if you send people out with a test strip, they're getting a one-time reading that usually is on a nice day because they're not going out in a storm to take a reading. They're going out when it's nice and they go, oh, everything's fine. So it wasn't until we deployed hundreds of stations all around the area that we were able to capture the things that were going on. And the same thing with trout. Trout like cool water. They will not reproduce properly if the water is warm. So we have sensors that read how high the water is, how cloudy the water is, but also what the temperature is. And what they found was in the Poconos Mountains, where people come from all over to go fishing there, they found out that a good number of the streams get too hot because of deforesting and other issues that are causing the water to have temperature issues. So we were able to help this one group, a small little watershed group that didn't have very much budget. They built 13 stations and put them out, and they've been running them for 6 years now. And they have an amazing data set of water clarity and temperature and depth. And they've been able to then take this data and write publications that then they give to the general public. They've been able to use it. Here's another creek in Philadelphia where they've been talking about the data they've collected with our stations. And they've been able to influence local policy based on the data they've collected. It wasn't just anecdotal, we think the stream is bad. They've actually said, here's months or years of data, here's what we would like to do to correct it. So it's been really useful for small groups who don't have big budgets to use low-cost instrumentation for affecting changes in their watershed. We've even got a couple of articles that we've published, another one coming out soon. So a couple of the main key takeaways from this whole project, when we are talking to groups who are like, well, I want to do the same thing. The big thing is, number one, have a goal for what you're doing. Don't just build a sensor and say, we're going to put this thing out and collect data. Well, you got to figure out, what sensor do you want? Why are you collecting the data? Have at least a goal. Don't just be willy-nilly collecting data all over. The other thing is to find leaders. So if you find one person in a group that says, hey, this group is going to build one, we want one of these loggers, but you don't have somebody who's actively going to take a role in it, the project's usually going to kind of fizzle. It's going to die out. A group's going to buy a sensor, they're going to put it out, but no one's going to maintain it. So if you're working with a group, you have to make sure that somebody there is going to kind of take the reins after you've showed them how to build this and assemble it. And along those same lines, you're going to need volunteers, which means more than one person. Don't just have one person go out to maintain this thing for years. They're going to get burned out. They're going to go on vacation. Things are going to happen. They're going to get fired. They're going to retire. There's, out of these 75 groups that we've worked with, we've seen, people change over for various reasons. And as soon as a new person comes in, they're like, what is this crazy circuit board? I didn't go to the 2-day workshop to learn how this works. So now you have to train a new person to learn how to use this. So that's where building capacity and what we call train the trainer. So you train someone who is now going to be kind of the local representative for that area. So when people have trouble and they need more help, they don't come to me, because I can't support the thousands of people that have bought this one board, because I would be, I need 3 or 4 clones in order to do all of what I do already. So if the more people you can train on your technology, the more flexibility you're going to have at being able to help anyone else that comes along. And the number one thing that is the same thing everywhere, you need funding, right? So luckily we've had big grants from organizations and watershed groups that have funded the development of the project, but a lot of it has just been things that we were able to take on as part of another larger project. Because of the low cost nature of open hardware, we could afford to do this. But you wouldn't really want to just start off with a major deployment and development program like this without having some sort of goal in mind. Having some sort of resources online for keeping that going, and the funding has been kind of an ongoing challenge. But so far we've been able to do it for over 10 years here, and we're still continuing on. We have a new version of our Mayfly board. I think the first thing that I told my boss when we were designing the board was, it's got to have a cool name. And we heard from Helen yesterday, who said, if you're making a project, it's got to have a cool name. Don't just call it the, basic data logger open source board or something, right? And so I call it the Mayfly, because the Mayfly is an indicator species. If you go to a stream and you turn over a rock and you see Mayfly larvae, or you see them flying in the air when they emerge, that means it's a clean stream. Mayflies will not live in a dirty stream. So the biologists that I work with will go out and actually physically turn over rocks with a magnifying glass and see what's there. If they find mayflies, then they know it's a cool stream. So I was like, let's just call this board the Mayfly. So that's where the name came from. And so further derivatives of this thing are probably going to have other names based off of other bugs and critters that we use there. But yeah, it's been a really fun ongoing project. If you want to know more, our website, envirodiy.org. It's a completely free thing to join. All of our repos, GitHub, the Eagle files for the data logger, the circuit boards. We have everything we need to be OSHWA certified. I just haven't gone through the last process of actually submitting it. But hopefully after I get back from the conference, I'll be able to submit that, and we'll have our own little tag on the back with our number on it. But it's been a wonderful project, and it's really great to be a part of the group here. And I'll be around later for any questions on this if anybody has them. But thank you for your time.
All right, we got more here. All right, and for our last set of talks here, you guys got everything set up over here? I've got Débora Swinstun and Sasha Engelmann, who are an anthropologist at the University of La Plata in Argentina and a master's of science in urban development and international cooperation. She's served in various international journals, and her book, Flammable: Environmental Suffering in an Argentine Shanty Town with Javier Ayero in Oxford 2008, won 4 international awards, inspired several public innovations in the dock sud port of Buenos Aires. And she currently teaches environmental humanities at the National Argentine University in Buenos Aires. Yeah, thank you. And I'll turn it over to you two.
Okay. Good morning, everybody, again, and thanks a lot for having us here. We are not engineers, as you listen. So the idea of our presentation is, first of all, we are in representation of another people also, part of the team that I will introduce also. And our idea is to share some of the constraints and challenges we were facing through the development of this project. That is a low-cost dispositive for the participative monitoring of air quality in this dock port area. The name, Sensora, this kind of female name, was chosen by the community we are working with, and that is the community I was born and raised also. Yeah, so we will share also why we are working on these topics and how this demand of environmental monitoring arises from the community and all the challenge we face to work with. And also we like to pose this question for the other presenters in the panel. So some words also to say how we are working together, because Sasha doesn't live in Argentina, but we met through artist that is Tomás Saracino. Maybe some of you know him, that he's working between science and art, thinking about climate change, air, and so on. So I met Sasha in 2008 in Paris in an exhibition, and from the beginning we connected kind of, and we feel that we have a lot of stuff in common. And I told her about this wish of my community to do some monitoring about air quality, specifically to how to produce devices to get data accessible, because there are some data coming from the government, has in all countries, but it's not accessible real for these communities. And also it's not pushing really good monitoring in the area. And also it's not changing the policy of air quality monitoring. So that's as part of our, let's say, our framework of working, that maybe you know all these figures about human health and well-being related with clean air, and how is this affecting a lot of people around the world. And also I think it raised this question among the other presenters. if we are talking about citizen science, or we prefer in our project, or at least in the communities we work with, something about more participatory science or community sensing, yeah, because they are not science, yeah, and the gaps, and for digital gaps, for example, and some others that we would like to talk also, it's very difficult to go so fast like you show in the other presentations. Yeah.
Yeah, so Joe, you were mentioning the edge activities that happen away from the real science, and you were talking about hardware and software development work, but I guess for us it was like these edge activities of working with communities whose bodies are most proximate to environmental harms. And what does that mean? And what are the kind of ethics of doing this work? So that was the kind of forefront, I think, of our project, rather than kind of rushing to make a device.
So those are sort of pictures about the neighborhood. Sometimes at night you have these deliveries of fumes, and then you smell a lot of stuff in the morning. And then some of the covers of the book is an ethnography about this community, and it's from an inside point of view of how is to deal with this in every day, how is to deal with toxicity, with uncertainties, with confusion, with a lot of different discourses around pollution, discourses from science, but also from the technician, from the local government, also from the doctors at the local center that sometimes they know, or they think there are relationship between air pollution and some of the affections that the community is suffering from, but some others time they don't have really all that information. And of course, there is no really a lot of interest from the government to become this information available. Yeah. And that was, for example, a really important constraint in the project. You know that one of the recommendations of the Environmental Protection Agency is to collocate low-cost air monitoring devices to fix and high-quality monitoring stations. We couldn't do that. Unfortunately, we got like the project stuck for 1.5 years until I say, okay, I need to go to another country to do this, because we came with a device that is there on the table, so you can get it also to look at, and I will share with you how we came with that specific design of the device. So one of the questions also for me to you that are more engineering, more technical experts, is how to quit in a proper way this constraint related this IPA recommendation. Also because in Argentina nowadays, there are no funds for science. So the laboratories dealing with gases and air monitoring or something similar to that are not functioning, are not working. Yeah. So I applied to a British Academy scholarship in the department of Sasha and Royal Holloway University of London. And we are dealing now with some colleagues of Sasha and Earth Sciences to try to collocate the device, the sensor device, in one of the monitoring stations in London, and to finally do this IPA recommendation. But of course, really, this question I pose to you is how we can quit kind of in a proper way this recommendation is important for us, because I won't be able to come every year to test another devices to calibrate them. So, so you have a clue about the area. The first picture is about the metropolitan area of Buenos Aires, and assume here, I'm zooming, this is the petrochemical port. So all these white dots are like tanks containing a lot of flammable products. So the community is called flammable. It's not that we post the name flammable in the book just because we want it. It's because the local government baptized that the community with that name after in an oil ship explosion in 1984. Yeah, and that was not the original name. The original name is poor neighborhood, yeah. And you have there like 11 petrochemical companies surrounding the neighborhood. So the neighborhood is kind of here, yeah. This was an ancient area of agriculture that was feeding the metropolitan area 100 years ago. And you have like there like 6,000 people living, and in 2001 there was the only epidemiological study showing that 50% of children there, they have like lead in blood like 3-4 times more than is recommended. It's supposed is recommended because there is no security also for a lot of gases and also for lead in health. So apart from that, in the metropolitan area, we are suffering from the dust from some fires due to climate change, due to, we have these dry seasons more frequently in summer and joined with heat waves. So with Sensora, we were doing through our Instagram or some others like social media, some recommendations, because it's something that is supposed that the Ministry of Health has to do. Like, it's simple stuff. It's not to begin panic to the people, no? It's just to say, if you have asthma, it's better you don't go outside to do exercises. You know, you have to put your air conditioning in a ventilation way. So it's simple stuff. So the government was not doing that, was doing like everything is like kind of normal. And we don't have like a lot of followers, no? But anyway, we were trying to help people through our social media network with this kind of recommendation. And I think I have to say and admit we were kind of innocent at the beginning of the project, because we were thinking, wow, this is awesome, this is amazing, this could bring a lot of information, a lot of communities that are not having, and it could help also the government to take better decisions, and no, that didn't happen. So in a sense, also what I want to say is like, this kind of technologies, I think, are giving like kind of, what to say this in English?
Partial perspective.
No, when you feel like it attracts you, all your attention, you became like, wow, but at the same time, it's a threat for them, yeah? So it's giving some fascination, and at the same time, it's a threat. So it's difficult to deal with that. So what I feel that here, what I'm learning is this kind of, first of all, there are more citizen science is more set in the normal, let's say, way of doing science, and maybe some local government collaborations or some community of science at local level. It's not the case in Argentina, and maybe in the global south also. So, so that's I said. Maybe you can say something about this compliment.
Yeah, so I guess, yes, thank you. Just as a academic joining the team from a university in London, I think this point about how we scale technologies is super important. So someone also mentioned that earlier. So from the beginning, this project was set in flammable, and it was meant to serve this one community of 6,000 people. And I think this question of like, can we scale? Can we use these devices elsewhere was really tempting. But also for us, it was like, okay, actually we have to come back to the original site, back to the original residents that are actually the ones that are experiencing these environmental harms, and think about how we develop a device that actually works for people in this neighborhood. And I think, yes.
So the shape, we came with the project in 2020, 2019. We got a seed grant, a small seed grant through the University of Sasha. And with that, we developed the device through the pandemic. So it was a huge challenge also because we were not able to go to the neighborhood, how much as I like. So we use a lot G-Forms, WhatsApp, some Google Meetings, and we designed kind of a form where we were sharing kind of each week some ideas of the shape, because I think you can show this picture of this one. We were looking at some other projects dealing with low-cost monitoring that also they were working with communities. And we wanted to move a little from this sense of this feeling of black box for the communities. That is, you open the device and you see a lot of cables and you don't want to touch nothing. So for us, because we are not engineers, we were testing all this ourselves, yeah? And it's not I'm critiquing you, yeah? It's not a critique for you, but it's the feeling that the people are not, they don't know about science, they don't know what engineering and technical stuff feel about these objects. Yeah, that are really useful, but I feel really apart from those objects. So we say, okay, how to build, how to develop a device that could be like touchable, that people don't feel they will break something if they get it, if they manipulate it. So we came with that design. So in the team, we have a lot of, we have like two industrial designers, and I have to say they help a lot with the inter-exchange with the community to think about a good design. Okay, my students of environmental science, people dealing with communication and social media, of course, the electronics and programming, and yeah, us, that especially I that I knew a lot about the community. So this is one of the first measures we did on the first testings, yeah, in 2021. That was the pandemic, and we entered anyway the monitoring station, just like squatting the monitoring station, I have to admit. There was no other possibility, kind of. And you have sometimes those fumes that people is burning, garbage, trash, or some cables to recover the copper inside and then to sell it, the copper. So also environmental pollutions in the global south are related with economic activities, not only maybe traffic or some things that I see here. Also, of course, with industries. So this tension between environment and work, between industries and environment, is really important in these neighborhoods and in this, because also people works in those companies. Yeah. So maybe you want to go on this part?
Yeah. So I guess, again, like thinking about ethics, thinking about protocols, thinking about how it is just as important which protocols for working with communities we set up as the instruments and the quote unquote real science. We had a few principles that underlie this project. First is about gender dimensions of working with technology. So I think it was very important for us to involve women and your students who are historically marginalized in relation to science and engineering. And there was also, I think, an important discussion around how we do north-south academic collaborative research. So there was one, I think, anecdote from a meeting where we had a bunch of scientists on this call, and one earth scientist was like, hey, Débora, can you just bag up some air from your neighborhood and send it back to our lab in London? And we're going to analyze that air and write an article and publish it. And Débora was like, but wait a second, like, how is that paper going to serve my community? How is that data going to be open to me? How is it going to serve our purposes? So I think there were moments in this collaboration that really showed the kind of inequalities in North-South academic research, and really showed to me how we needed protocols for collaboration that really ensured that the data was going to be used to serve the community of Flammable and not to serve my needs as a Global North academic or the needs of my colleagues. We have a memo of understanding that says that the data is owned by members of the Flammable community. It is not owned by me or my colleagues at Royal Holloway, and it cannot be used or published by us. So again, like, we're really working through a lot of, I guess, open questions, critical questions, technology questions. We have a device that, if you understood correctly, cannot be calibrated in Argentina under current infrastructure, which is why Débora is even in London doing a fellowship. We have a lot of barriers to access in the community that we're trying to deploy it in, where people have power supply shortages, water shortages, incredible forms of pressure to sustain lives. And we're trying to work, I guess, in all these contexts to do something that has not been done before, make air quality data that serves a community called Flammable, and that really serves the ends of residents in that neighborhood. Is that fair? Yeah.
Thank you, Sasha. And the last aspect maybe is this issue about high cost. Is to lose nowadays. I have to admit, we are losing part of the team because I cannot support them like with finance, yeah, because a lot of money. I mean, the money we got was coming from science projects, some seed grants, and especially from the universities. So we also, one question for us is to help us to see how to move forward and in which organizations or foundations or whatever we could apply for funding to continue the project. Really, it's a really pragmatic question what I'm posing, but it's very important for the project. And also this issue about, we can talk all the time in these participatory action research projects, as I would like to call them, to name them, about do it yourself. I cannot say that a community in Flammable, even if we do a manual, that's we're trying to do also a manual for Sensora, just they can reproduce the device by themselves. Yeah, there are huge gaps in education, inequalities, and internet access, and in understanding even. I mean, so yeah, that's mainly. Yeah, and you have there you can access our webpage, some emails to contact to continue in touch with you. So thanks a lot.
Thank you. It was excellent. All right. I think probably the best way to approach this is, why don't we have our panelists come down here and sit? We'll keep it a wide net first initially. If anyone has a lot of opinions too, they're more than welcome to come sit down here. Yeah, have a seat. I'll have a seat. Come on up. So unfortunately, just given how this room's set up, the live stream's not going to catch everyone, but you should be able to hear everything. And maybe I'll stand over here so you're not looking at an empty screen. So the cool thing about being the moderator is I get to ask a question. So I have this question, and this has been rolling over my head. I actually asked this at a couple different places last week. Particularly, I was at the big academic robotics conference. And the thing we have going on right now, and I used to work on like satellite imaging, we have all this data. We have temporal data. We now have 3D data. You can put a drone of some sort or a vehicle of some sort, collect a bunch of three-dimensional data. You can collect sensor data that's temporal. And there's just so many different modalities. And Joe, you worked with OSM data initially, right? Or at some point? So a lot of the mapping technologies we have are very two-dimensional in nature, right? At least in terms of open source, in terms of things you can grab and build and take data and then present it to people in a useful way. And I'd be really interested to hear from everyone here if we could think about new kinds of tooling that would be easy to use, that would make it easier to share and present data that everyone is collecting in a way that's very actionable. So for example, at least in California, I know when we have fires or the oil refinery near us vents a bunch of toxic gas, I can go on, say, Purple Air, and I can see real time, this is where the areas are bad, this is where the areas are good. But to make that tooling for an open source environment, you have to do a ton of work, and it's very bespoke, and you'll make one map for one website, and that's probably a lot of overhead for people who are potentially not software developers or not front-end developers. So I'd be curious to hear people's thoughts on what kind of tooling you'd like to see to make some of this data accessible and shareable and presentable to people so we can actually make changes to the world as we see it now. Should we just do right to left, or if you have thoughts, if you don't have thoughts? You've done this.
Yeah. Well, I know with ours, we have a data portal. It originally started with just a MySQL database that I wrote myself, and I went to like dreamhost.com and got a free thing, because as an individual you can get a certain amount of space, and I found examples online of how to make Google charts embedded into websites to use it with the time series data. And we did that for a number of years until we ended up with dozens and then hundreds of users who were sending 8 to 10 or 12 data points every 5 minutes. And then at the rate we are now, we collect about 20 to 25 million data points a month. And there's no way you can do that on a homegrown, really basic site. So we've had to outsource our data management for the processing of the data we've collected to a consulting firm who just handles the website, and they've got like 10 people there that are constantly working on it, and it's not cheap. It's very expensive to do that, and we had been able to fund that with various grants over the years, specifically just for the data. So we have like the whole hardware side of things, and then we have like just the database side. Because that's the biggest problem with regular citizen scientists collecting data. When they go out to their data logger and they remove a card, they have a CSV file, a comma separated values. Some people know what to do with a CSV in a spreadsheet. Some people don't. Some people have never opened up a spreadsheet. A lot of them don't have a Microsoft Office, license, so they might use some free spreadsheet program, but they still don't know how to then take the data, and then now you have a graph made of some data. How are you going to clean that and process it? So there's a big step between collecting data and then making something useful of the data, and that's where we've applied for all sorts of grants, and there's more money to develop hardware. People are like, hey, cool shiny little box. Nobody wants to give money to somebody to just do some cool stuff with some endless CSV files. So it's extremely hard to get the funding for that. We had applied to a whole bunch just in the last 6 months or so, but almost all of our grants, I worked with small NGOs, so most of our suppliers of the grants that we work with are U.S. government, science foundations and things like that. So we've had to shift our focus to finding smaller organizations that will hopefully see the benefit of providing funding for those options. So I'm curious to see if anybody else here has ideas on how to make large data sets more accessible to citizens who don't normally have a university or a bunch of grad students who are going to pore over the data like normal. Most scientists will be like, oh, I've got like undergrads or grad students or postdocs who will just happily look at data for 3 years and then make a chart at the end of it. But most citizen people don't have the access to that, academic slave labor type of thing that normally happens in the universities that I've been working with over the years. So that's our biggest hurdle now, is taking all this wonderful collected data and making a nice product with it at the end that the citizens can actually understand and use.
Yeah. I think you have to, let's say, alphabetize. Sounds weird, this word, but I think it's like that. You have to do workshops. As you do workshops to build or to reproduce the like sensor or the devices you work with, we have to do also that. But also for us, I think we were thinking all the time, and it's because also we met through an artist, that we need to involve the artists in this, especially. So one of the, for example, one of the workshops we thought with the community is to use our bodies for sensing and just to try to do this connection between how our bodies are feeling the gases, everything that is surrounding us and that is exposing us to harms, to that, because they have a knowledge about that. And when you show that connection between what they felt in their bodies and how that is in a graphic showing these peaks you were showing, they really understand what is the issue, what is the problem. Because the way of building knowledge for them is, wow, I felt this putrid egg smell. So, it's, yeah.
150 and now I feel sick, or I feel sick, so I check.
Exactly. Or my eyes are in this, or my nose, or what, or I'm coughing, whatever. They have a knowledge and they feel the environment like that. So I think that kind of connection is really useful in a sense. And also we thought about workshop to put the parts of the device, like parts of the body. I mean, also the engineers, they thought about it. They say, okay, just the PCB is kind of the brain that is, processing everything. The sensors is our nose, is our skin, the screen, our eyes. So they were doing this kind of metaphors and analogies and comparisons, and this helped a lot also the community. So, of course, we need to think about to use our creativity. And I think the issue is to become together, kind of, the engineering, the social scientists, the environmental science, the artists. It's because I don't think there is another way, kind of. But in our experience, when you show you can do this everyday connection of how they are producing knowledge and information, because in this sense, of using their own bodies, they are producing a kind of information that is helping us to move in their surroundings, and not to take this kind of protective measurement, these protective actions to not to be exposed, So that could be a possibility.
That was great. Thanks, Débora. And I think I would just add, in this summit as a whole, this idea of new kinds of tooling seems to be what most people are proposing. Countless talks yesterday were about new devices, new instruments, new and exciting tools. And I guess for us, these are not always good. So a gigantic data set or website that puts together air quality data from flammable may reveal things about residents that is actually really bad for them to have revealed. Argentina's government currently is very hostile to people making environmental knowledge in these underserved communities. Under the authority of Javier Milei, science is being gutted and defunded and threatened. So I think, again, asking these questions before we see new tools emerging or new kind of platforms emerging, whose lives are most proximate to these data sets, who is most at risk, who is going to be affected by data on air quality being made public for science, right, or even for public policy. And yeah, I just think maybe it's provocative, but as a social scientist, I think asking these questions about why we default to new tools and why we think that putting data online is the right thing to do. But that was kind of related to your presentation as well.
Thank you. There's several strands to this, aren't there? I'll connect to that one first, and then come back to your original question, which I did really like. So the FDRI project that I mentioned is it's water quality and water related risk rather than air quality, but similar picture, and it's got a lot of funding now, but it doesn't have that long-term horizon. And this is a theme I'm hearing over and over again: the need for support for maintenance, both in terms of investment and social support. So right now, that project is building out a lot of data services, APIs, trying to hold workshops with stakeholders, local user groups, but it's all running on Amazon Web Services because there is the budget for that now and there's the discount for that now. I'd love to see something more like a regional consortium of university infrastructure or similar bodies to UKCH to support these services. I think the US has or had better models for that kind of thing with the Open Storage Network. Then the other question about kind of flat interfaces and wanting that a lot of what we've got now is really screen based. And when I think of some of Libby Miller's prototype work and the importance of taking people away from screens, what can we do that's adaptive? So like in the mapping space, there's lots of 3D printed maps that give you a sort of a texture to explore, a kind of, Braille-like, but it's basically a 3D model of the structure. But how do you keep melting that and evolving it? It's a lovely question. There's sonification work. That's what I've seen Libby doing recently, like sonification of accounts data, so you can visualize how much the business is bringing in each day. Or and we did leave an extra stool here in case anyone feels compelled to come and answer any of these questions. Then there is space to just jump up and become part of this.
Well, we got plenty of time. I'll open up. Does anyone have questions, thoughts, concerns? Hop right up.
Thank you for all these nice inputs. So I have one question. You have all this data, and in Pennsylvania, you have a really huge community. And is there any part in your project and like kind of an action pipeline? For example, you measured the salt peaks and the community is quite big. So I think they could have quite an impact to put some action, some pressure, some political pressure, some activism. And I'm wondering how to implement this action pipeline directly in the data. For example, if the air quality is really bad and I see that, or if it's really noisy, I feel really angry. So maybe I even avoid to look at the data because I feel helpless because there's no action pipeline behind it. And is there anything in your projects that help with that step from data to action?
So, you have any thoughts on this? How do we go from data to actually doing something useful with it? It's always a big problem.
The quick answer from my particular organization is we are an independent scientific group, and we are not asked to provide an opinion and to have any. We're just there to be unbiased and collect information. So we will collect that data and we will help people interpret it. But my particular organization is not like people come to us and go, I've got somebody who's polluting. I want to nail them. We're like, well, we will provide sensors. We will help you interpret the data, but we're not going to write a paper or help you, go to your local council and tell you what to say. Like that's on them because we're trying to be completely unbiased scientists collecting the data. But we do have groups that we have consulted for to give them that data, and we let them do it. But that said, there was a project a few years ago where a local power company wanted to know how warm they could make the water coming out of their power plant, where it wouldn't kill the small fish and other animals. So we built this is before my time, but they built an amazing experiment with hundreds of tanks, and they used small fish and bugs and other things, and they changed the temperature in these tanks at different rates, at different amounts. And they did this for a number of years and collected all this data. And the power company had originally come and said, hey, can we raise the temperature of the water 0.5 degrees Celsius every hour? Or is that going to harm the fish? And what we found was they could actually raise it like 2 degrees Celsius before it would actually cause a problem. So we thought, oh boy, well, this is going to be great. We're going to give them data to help them stop thermal pollution. But what our data showed was that it actually really wasn't the temperature change that you give the fish, it's the rate of change. If it changes too fast, they can't accommodate that. So we were able to provide them scientifically sound data, but it was not what the scientists and any environmentalists would really like. But we actually, after 2 years of research on like millions of small animals, they were able to decide, what would work. And that was like 20, 25 years ago. And the power company still uses those numbers as it's not written in regulation, but it's what their internal numbers are. So at least we know we're happy that they're not damaging the fish, but we were able to give them a real number, not just based on feeling or emotion, but what was scientifically true. And the same thing with the salt stuff. We do know that the salt is a pollution type thing. So what the scientists are studying now is 6 hours of salt water bad? Is 12 hours bad? Like what is the bad number that then we can be on the lookout for? And then when that happens, we give that data to the local groups and let them handle that. So that's how my organization works, at least.
Thinking about the effects of environmental data and also about human health. In inflammable, I don't know if you remember, I mentioned this epidemiological study showing 50% of children with lead in blood. And that epidemiological study that implied also some environmental testing in water, in soil, and in air for the first time in this port area, it helped with a group of different grassroots and NGOs and environmental foundations just rising at that moment in Argentina to build something like could be like in United States a class action. And with all that information, the Supreme Court ruled the cleaning up of the river basin area of Matanza-Riachuelo River, that is the main river crossing all Buenos Aires. So that was in 2008, and it was built also an authority of a river basin that is working like, let's say, environmental agency controlling the industries, trying to put, like, let's say, an order, kind of an urban planning and zoning in the area. So for sure, I think that environmental data helps a lot, and especially when the communities are requesting for that. So in a sense, in our project, we are really careful to deploying the devices, because when we ran the first workshops, the community was just asking, okay, I want to know exactly what we are breathing. So it's like we are not, given, they want the device, and we were explaining that really still is a prototype, that is experimental, that we have to do this collocation that is recommending because it's kind of low-cost sensors. They really understood that, and they are waiting for that. And for sure, I know because they are like, they have some grassroots organizations that are some environmental lawyers involved, they will do something with that. Yeah, and of course, you never know what will happen with that, no? But just there is a good example with this ruling of the Supreme Court using this environmental study and some other environmental data. So, yeah, I mean, I prefer to think it's possible, even if the context maybe is constraining you. But I think the communities, at the end, they are really smart about a lot of stuff that even you, like a science, or even I, coming from that community, even sometimes I cannot like imagine, you know, how the thing will develop. Yeah.
But the Supreme Court ruling, is it still in effect?
Kind of still is a fact, but of course, with this new president, is 5 people, and yeah, it's said that the companies could pollute whatever they want. Yeah, it's not good, of course, but the people is aware anyway, and they won't just give up because the government is doing that. Yeah.
Thank you. I think institutionally the answer is probably the same as Shannon's. A neutral observer organization. It is a lovely idea for an experiment, and I think there are some projects at UKCH that I don't know much about. Possibly Rob knows more about, where they are observing the side effects of attempts to make positive environmental change, like change fertilizer types so that there's less runoff of chemicals into lake, which then stir algae cultures, which then have an effect on the plankton and those sort of cyclical ecosystemic effects. But it's not part of one continuous experiment. It's changes that are being made somewhere else. You would have to sort of have a control site where you intentionally did nothing, and that would be difficult because everywhere is different. It's a good question.
Yeah, I wanted to add just something more, that even for this ruling, as I remember, also the lawyers took some passages of the flammable ethnography that was published in the book to build the claim and to present all the data. So for them was also interesting how they combine so let's say social or more soft information with environmental data, yeah, to build that. And also thinking about what you are mentioning about the different organizations you are with. I think in Latin America specifically, we have this long tradition of science also involved in public policy. This is why the universities are public also. So always you are thinking how you will give back, your education kind of. So in my case, for example, after the publication of that ethnography, I was called by the national government to get involved in the development and design of this huge cleaning up plan for the river basin. And I accepted. And at that moment, for me, I have an offer to go to study to US with another colleagues who were. Was a really tensionable situation, but I say, yeah, I mean, I know I can do something. And we did a lot for 20 years now. Yeah. So decisions. Yeah. Of course, comes another government like we have nowadays, can change a lot of stuff. But yeah, that moment was what I felt it was for me good to do. I mean,
It sounds like there's a lot of tension between, we don't need a device to tell us what we know with our own eyes, and there's ramifications for building that and using that device. And then also, but it also helps to have actual data to say this is specifically what's happening. And there's a tension you have to work through there. That's both ways. We have more questions. Oh, so many questions. Great. I'm going to go here. I'm going to work right to left.
Thank you very much. Clear talks.
My question is to Shannon, because you mentioned about collaboration, but also having a board. I mean, it's becoming maybe a running joke, because yesterday we also had yet another microcontroller, but we also have yet another environment monitoring platform issue. The question is that what's the problem? If people in this field of open hardware all know so well that we need to collaborate, why are there so many systems out there, and why people have to start all over again and they don't sort of communicate? Or why forking and not sort of adopting? What happens? Is it the funding system that bothers it, or is it the ego, or is it just I want a solution tomorrow or yesterday? What's the problem, because you've been doing this for 10 years?
Oh my God. So we solve this problem that is going on with everything in open source right now. Everyone's building 5 versions of the same thing.
Yeah, well, one of the interesting things that I've noticed, I go to a lot of academic conferences multiple times a year, because I work with professors and students and everything. And what I notice is I go to a conference and I see posters and presentations, and it's a postdoc student, or maybe an undergrad, or some sort of student that's just there for 1 or 2 or 3 years, and they invent something really cool, and it can be open source. I go to a session every year made up of it's the American Geophysical Union. So it's about 25 scientists, or 25,000 scientists, that academic scientists in the US and from all over the world. And we have a session called the MacGyver sessions, and there's 25 or 30 of us that all come together, and we have a poster, and we have workshops, and we have all of our gadgets where we're MacGyvering instrumentation for environmental science work, for geophysical monitoring. And it's really amazing. People are making sensors out of paper clips and bubble gum, just like, the MacGyver TV show where you're inventing weird stuff. But it's 90% of the people who come to those sessions are students who will be graduating soon, or they've already graduated and they just came to present, and then they go on and they have a job and they do something else, and they go work for corporate America or some other institution where they have to, patent their stuff and they can't share it. And I've met some of them over the years who are now at big corporations doing amazing things, but they are no longer doing the open source sharing. I luckily worked for the same company for the last 15 years, and they're like, my bosses are like 100% everything is open source. We're not closing anything, just work on this. And I've just seen an amazing turnover of people in the world that I work with, of people. There's sometimes a professor here or there, but the students who are actually doing the work and coming up with the ideas are gone within a year or two. And the new student comes in and they don't want to work on the thing that somebody else invented. They want to come up with their own thing. So the churn of the actual development stuff is constantly changing. And along the same rate with my board, I have to keep changing it, because every year 1 or 2 or 3 parts becomes obsolete. And now this other thing that used to work doesn't work anymore. The processor I'm using is 9 years old now, and it now costs 5 times what it did when I first started making the board. And now I can use a bigger chip that has more memory and more RAM for 1/3 the cost. So why not do that? So there's the ongoing, technological changes, but the personnel at these places are constantly changing. So it's a really hard thing to keep on top of.
Ask a supplementary to that. Why does someone who comes in to do science feel the need to invent a new board? If they're doing science, what is it that attracts them to making yet another?
Well, that's the thing, is usually, it comes down to 2 things. One is, do they have the money to buy some off-the-shelf thing? Like a lot of times, so this instrumentation that there's only 10 or 15 people in the world doing some sort of spectrometry with some sort of instrument. The machines can cost $20,000, $30,000, $50,000, and the research budget of these programs is really, really small. So what happens if you get a professor or a PI at some institution who has some students who have some really good technical skills, and they like, hey, we need 3 or 4 or 5 of these instruments that cost. It's what we did at my place. We wanted to buy an optical spectrophotometer for real-time stream nutrient measurement. The machines cost $50,000 each. We were able to build them for about $500 each. So we could now deploy more of them with a fraction of the budget and collect all sorts of great data. So yeah, we're inventing something that already exists, but at a fraction of the cost. And that's why we invented what we did. And the same thing with the data logger. The data loggers that we have can cost anywhere from $1,000 to $2,000 each, and they still don't have all the features we wanted. So that's why we're inventing it. And I feel like most of the time it's a budgetary thing where people are like, if a commercial thing costs the same as what it would cost for me to make it, then I would do it. But it's usually the people and the students and the people who are creating things, their time is essentially free. So it's just like, hey, you like electronics as a hobby, invent this thing so I don't have to pay for one over here. And I think that's where a lot of the professors and the people running these labs see the hackers as free slave labor to invent really cool low-cost products that they don't have to buy from a big company. At least in the groups that I've worked with, that's the motivation that I've seen from them.
Yeah. Another answer to your question, which is that one I want to ask, even if it is a bit abstract, is that the question makes a lot of assumptions about what science is, and the word is, and I think you've alluded to this a few times, Sasha, and the real science, TM with a capital S, and you slap that label on an activity, and citizen science happens over here. So, if they're experimenting, they're inventing, they're creating a physical publication that other people can replicate. How is that not science? Is the concept still as useful to us as it could be? I try to avoid using the word, not always successfully. I don't like calling people scientists because it carries with it that assumption that if you don't have that label, you're not we're all scientists.
Yeah, and I think just relationships to both instruments, but also labor, is very different in the global South versus in the global North, right? So these are questions that I think we have to ask in different kinds of contexts that have very different implications.
That it's not really reinventing a new platform everywhere. It's more like it's a weird way of iterations. For example, you have the knowledge of, I don't know, for example, your platform, and then it's kind of a similar thing to, I don't know, to send data somewhere, but then you don't want to use a handout, or you have a problem to connect the devices with the IP address, all this stuff, and then suddenly there's a new technology coming out, and in Berlin, for example, then we use like a new iteration, and it's easier to start from scratch than to look at all the things that you do, maybe, and so it's like this kind of, I think it's a collaboration is going on, I think, underneath somehow that is working on like inspiration, but it's not, because the development already takes so much time that it's important that there's not really the time to really connect really deep, and that's why sometimes it's just, you can just grab a little bit the best of, and then do it from scratch. That's
Questions, comments? Go over here because
well, I probably don't need it, but hello. Sort of carrying on that theme, I think in my sort of meanderings around open source hardware and open culture, I think there's a definite difference between open hardware and open software projects that aren't directly kind of born out of or directly linked to kind of academia, and those open source projects that come straight out of academic kind of programs or straight out of universities. And I think there is a real difference observable about replication of other projects and reinventing the wheel. And I think some of the things in academia kind of can push for that. So like, it was really interesting for me listening to the Quetzal 1 talk yesterday, having been involved as a core contributor to LibreSpace Space Foundation, and knowing that in 2018, and this is not a dig, like Quetzal's an amazing mission, but they had access to like a global decentralized really, really well put together ground station network, but they still invented their own ground station system. And then we, members of our community backported their data telemetry so it worked with ours, and like everybody globally could monitor it. And it's like, why do they do that? And I don't know in their particular instance, but it's observable that I know lots of stories where there's been an academic that says, I want my people on the RF track to design a ground station. And so they have to go through the whole thing, and it might be really, really close to what SatNogs is, but it can't be SatNogs because that's what they want. And then the other thing is, I think academics are quite often motivated to do open source hardware projects with an eye on their students looking to go into an industry, and more and more they want to do something that's publicly showable as a portfolio piece before they probably go into a closed environment where they don't get the opportunity to do that. And I think that's wonderful that open source, interviewers looking at people's GitHub profiles and stuff is part of it. I think that's kind of wonderful, but I also think it's dangerous because it makes people want to reinvent things and make individual things, when as a movement we could be so much better if we all just aligned on a few things, eh?
Oh, absolutely.
As somebody who's built an somebody who's built an academic or an educational robot, I have said several times, like, the world does not need more educational robots. We need everyone to work on one, so we have a curriculum that everyone can use, because the people teaching it aren't roboticists. This is an unsolved problem in open source, but it like needs to be solved, I think, for things to get bigger. I'm gonna give it to somebody new here real quick.
Hi. So my question was, we've got all these open networks that give us data. Is how do you ensure that data is half decent quality? So you've got the Purple Air network, where my institute had 2 sensors, and I saw one was reading weirdly high and realized there's actually a spider web inside of it. So we've got these sensor networks where there's thousands of nodes across the world. How do you know that it's producing good data? Like, is the sensor beside an exhaust? So beyond putting a 360-degree camera on all your sensors, how do you ensure it's good data while also maintaining some level of privacy for the person who's took up their time to put it out? And then I had another very specific question about the Mayfly. Does it support SDI 12? I've had a nightmare trying to get that working with Arduino. So.
Hey.
He's now at MIT as like a professor, but we hired him and we said, how long will you need to crack the SDI 12 protocol? And he said, I don't know. And he came back the next day. Like, we hired him for 6 weeks. The next morning, he had written software all night long to do it. So we've been able to do SDI 12 with any Arduino board with no other software. It's all BitBang. And we shared it. If you go to GitHub and just type SDI 12 and Arduino, you'll find our repo. It's tagged in along with Mayfly and Enviro DIY stuff, but it'll work with an Uno or a Mega or any of those. So SDI 12 is a serial data interface at 1200 baud. It's an industrial, mostly environmental sensor protocol. You started by the U.S. Geological Survey back in the late 1980s, and you'll usually only find it on environmental sensors, but it's very particular to environmental sensors, and you can't really talk to it. There are people who make adapters that go between an Arduino board and that sensor, but we wanted to be able to do it directly from the sensor, so we can do that now. Oh, and then the first question was data quality stuff. So yeah, that was like the whole point of the third and sometimes 4 workshops that we give is quality assurance, quality control, QA/QC workshops, where we teach people how to go out with secondary, calibrated meters and put that in the water next to where you're taking a reading. Take a thermometer, use a calibration solution, using standard lab practices to test your field instruments at a regular interval, and document that so that then you can prove that your data is sound and accurate. Because some of our data that we've collected with our sensors has ended up in legal cases in front of federal juries where they have had to show how the provenance of our data and how accurate it was, which is the reason why in that photo you see of all the sensors that we have used, every single one was a commercial calibrated sensor that has some sort of traceable information. The main project we use, we don't use like homemade sensors made out of little random things, because in a court of law or in some regulatory agency, it's kind of hard to prove whether it was accurate or not. So we use homemade loggers, but commercial sensors. For other projects, I do use, $5 little, you take a dishwasher sensor and put it in the water and it'll tell you how cloudy the water is, but nobody's going to believe that unless you use a $1,500 optical turbidity sensor. But you can put the two side by side, see how they do, and kind of get some relative stuff. But we do have to do an amazing amount of legwork to make sure that our data is defendable.
You also have calibration problems, especially in Argentina. I'd love to hear more about this because this sounds fascinating.
Okay, it happened that we received some also awards because of the design of an innovation concourse in 2022. And a letter of expression of support of the National Institute of Technology and Industry of Argentina, that is INTI, that we are used to do kind of testing and calibration of different scientific equipments. But what happened is that at the end, they told us I could do the analytical part of the analysis of the data. Yeah. But I have to be sincere, they told me that we don't have anymore our gases lab for environmental measurements. They are only working with chimneys and filters. So it's not possible to put the Sensora device next to a chimney and comparing with that. So, okay, so I say, because at the first time I say, just now, we solved the issue, we solved the problem. It was not the case. So then we went to another national organism, and it was the moment of this governmental transition, and they told me we have some monitoring equipment on the terrace. The issue is we cannot guarantee security for the devices because they have an intervention from the government. So all that sounds very weird maybe for you is a part of the context. Yeah, and we got stuck the project really. Just we have like 6 devices to be tested, to be calibrated after this award. We use part of that fund to reproduce more and do the calibration. So then I try with this authority of the river basin, because they have like 2 high-tech monitoring stations in the metropolitan area. And they were telling me at the beginning that, yes, this history I told about the fascination that the device produced, because some of the technical experts, they were saying, wow, this is fantastic. We will have now a tool to go when the communities are calling us and to say, oh, we have these chimneys throwing this, or we have that other fumes, we are smelling this, we don't know what it is. Yeah. So I say, wow, that's cool. And this is one of the objectives of the project. But it became a division inside the organism. Yeah, the technical experts, they were supporting to move forward and to help to move forward the projects, and more the political authorities, they were feeling, as I mentioned, like it's a threat, that this device is a threat for them. Because what you will do with environmental data? The people still is not so much aware about the problems of dust coming from fires and environmental pollution and health and air. But the problem is there anyway. So in Global South, we deal with this issue that is really root related with this tension between environment and industry and development, and work, and the threat that the companies will leave the country if you start to control them even stronger. So it's difficult, it's complex. We don't give up, so I apply to this scholarship to do this, at least just to know if all the sensors we choose for this device, that we did a lot of research, are the proper sensors for this device, or we have to do something else or something different. Yeah, and that's mainly the story.
So the existing infrastructure kind of exists to perpetuate what's already there. And have higher resolution
Exactly,
and other-
exactly. There is these fixed monitoring stations, but we were not allowed to do this collaboration
You
kind
can't
of.
just
But
sit there with your sense and be like, is this actually true? Who's wrong?
tie it to the fence.
Tie it to the fence.
So I went to this station of Akumar with a collaborator of ours. And as soon as we drove up, we just went to see the station. Someone else drove up and was like, why are you here? What are you doing? Like, what's your, and so actually my collaborator had like about an hour phone call with someone just because of our presence next to this station. So we've been working on Sensora for 5 years. It is not calibrated. And we need help. Yeah, that looks like that. So we were co-locating Sensora with the scientific monitoring instruments at that station that's very near to the neighborhood that we're measuring in. And that was where we had this encounter. And so it's highly policed and surveilled. And
Is your problem calibrating that or that?
that, yeah,
Okay. No, just to clarify.
yeah.
yeah, but you know, this is a good point. Let me show you something
Well,
that we
I'm
discovered.
calibrating sensors at the moment in my height. I've got 4 for varying levels of price, and I can just then track on the graphs. So it's quite often a case of just having several of that sort of thing.
But this is a good point you raise, because when we were doing this kind of, you remember I talked about we were getting this dust from this wildfires related with heat and the dry season. This is a low tech, let's say, or low cost, yeah, a device that is in another locality. This is information coming from the supposed high-tech monitoring station, and these are the figures we got in Sensora. So you see 55, and they are also 55, yeah, or PM 2.5. But in the local, the authority monitoring station, you have 26 score. So I show this in a presentation I have with this local authority, just to check if the way of the we're doing calibration is different, or if there is a problem. So this supposed collaboration became even worse after this. But it is an important point you raise, because really I don't know now if we can do a collocation with that.
I
Station.
have one of those
Wait.
next to there, so you can compare it, but I fully understand.
Yeah. I don't know how is your experience with this kind of collocation processes that is similar or just. So some of the technical experts inside the organism, they were telling, I think I will trust more in your device. Yeah, but you need to prove that. So how you do that? Yeah. So one of the questions I posed here was like, how we quit this? Like engineering, high electronics, you know, how there are other kinds of platforms or whatever to do this testing, to do this calibration.
And I guess the sensors that we're more worried about calibrating are not the PM10 or PM2.5. It's the 4 gas sensors that we have on the device from AlphaSense, which is extremely difficult to get good calibration details from AlphaSense. I'm not sure if others have had this experience. I'm seeing some nods. But also for a project like ours, already having so many barriers to access and calibration, and then to be kind of forced to use sensors from a company who are the only ones producing like so-called low-cost gas sensors for our needs, at least recommended by scientists at my university, and then to be withheld information about how to properly calibrate. So there were all kinds of issues with calibration that I think came from many different directions and are ongoing.
Thanks.
So it sounds like, at least in the US, we still, for the time being, have NIST. It sounds like something that would be really helpful, especially from like Western universities, is providing for citizen scientists, for all individuals, the capability to do high-end calibration as a a trusted source, right? Because that's really a missing piece on a lot of these sensors. Does that jive? Co-location. I mean, there's similar things. All right, I'll do one more question up here, and then we got a timeout. But you guys can all chat too over coffee or tea.
I'll try to make this a very brief comment. Whether it's an issue like sort of calibration kind of problems, or a feature request, something like a protocol that you're looking for, the ID12 or whatever that was. In open hardware projects, don't be afraid to document that in like an open bug or a thread of some kind. It might take years for like a new master's student or someone else to find that, but it could be much easier for whatever project they're working on to kind of implement that in your hardware. That might save them time, that might improve your product. And it's something that proprietary kind of systems often can't do because they're not making their problems, excuse me, and limitations so open. So yeah, don't be afraid to document problems, even if they'll be open for years and might seem like it's not worth doing.
I tell everyone, please file an issue. Please don't send me a Discord message. Please just file an issue. You guys have any comments on this? How are you guys handling bug tracking? Oh, yeah. What?
So regarding this is with AlphaSense, but many of the other things that we've been seeing here, it's in different parts of the world, we're seeing exactly the same effort. We've been through AlphaSense 8 years ago, where we had exactly the same issues. We did collocations in Barcelona. Now we have hundreds of sensors in Europe. I think that we're lacking a place where we can discuss this in an open way. There is enough people in this room. There's enough people doing exactly the same thing in the world. I could have benefit greatly from knowing Enviro DIY 3 years ago. You could benefit greatly from knowing what we have done on AlphaSense. I could have benefit greatly for knowing what you guys are doing on other projects, right? And I feel like we're kind of chasing the same ghosts somehow, from different perspectives, from academia, from the hacker world. I'm an engineer myself, but I work in a fab lab. I work a lot with academics, and we have the same questions. We talk about the same thing over and over and over. People don't trust data, and that is not a question of technology. That is a question of power at the end. There's a question of monetary resources, economics, power, and relationships that don't pertain to just technology that we're not going to just solve with, I don't think, with an individual project. That goes as a systemic issue that unless that we find a way to at least come together in a room and generate enough critical mass for people to discuss around these topics in a way that ends up making more critical mass and snowballing somehow, it feels like we're going to chase this over and over. And they have much better power. We're losing the fight in a way, right? If we are concerned about the environment, we're really losing the fight. And that's happening, right? It keeps degrading. We see climate change. We see pollution. We see biodiversity degradation, mass extinction. And I don't want to doomsday. We want to go for a coffee. But really, this is happening, right? I mean, and what are we doing? We're just chasing funding. We're just trying to do our own publications, our own new device. Why? Why are we doing this if our ultimate concern is to try to make our environment a better place, but yet we still do something that it's going to benefit us academically or economically, or just give us the hype of having designed something, produced it, and it working? I love that hype as well. I mean, we're all hackers in a way here, right? I love sewing and soldering and when things blink and stuff like that, but let's not lose north of what we're trying to achieve, at least in this conversation. No? So I kind of feel like what can we do after this hour discussion? What kind of forum, what kind of place can we have so that we can discuss these things and not have to chase endless ghosts all the time, right? So that's an open question to everybody.
Well, we do have to have lunch, but all of you that have comments or questions can just go up here and talk to each other. Very short, 1-2 word.
It will help a lot if OSHWA certifies people, because I have money, I cannot find people. Yeah, open hardware people.
Everyone's certified.
That's it. Probably most people here are in the Gathering for Open Science Hardware forums, and if you're not, I'd recommend joining them. They've got a quite active discourse instance and perhaps a thread there, possibly taking over one of their regular meetups. So the Gathering for Open Science Hardware. That's right. Yeah. Gosh.
And can we give our panelists one last round of applause? This was fantastic.